Okay, we're going to finish chapter 9 with 9.7 and the other trig graphs. So these are the inverse functions and tangent. So let's start with secant of x. Secant has a domain of x is all real numbers except the 2n plus 1 over or times pi over 2. What this means is there's an asymptote at pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and so on and so forth, both positive and negative. So we're going to put an asymptote here. We're going to put, should it be? It's not at pi. 3 pi over 2. Yeah. And then 5 pi over 2. Sorry. So we're going to have an asymptote there, an asymptote there, we're going to have an asymptote there. So if you look, there's 2 spaces in between each of those. The range is negative infinity to negative 1 and 1 to infinity, meaning there's going to be a gap between these 2 blue lines. The period of secant is 2 pi, which makes sense because secant, remember, is 1 over cosine x. There's no x-intercepts and no max and min on this. So the way it looks is you've got a graph here, you've got a curve here, you've got a curve here, which will in theory keep, or in reality keep going, and so on and so forth. So it looks like this. Now I'm going to draw the cosine graph. So if you look at the green cosine graph, y is 1 over cosine. So the blue pieces are just that flipped. And wherever it hits 0, remember you can't have 0 on the bottom of a fraction, that's why you get those asymptotes. But that is your secant graph. On Desmos, you can just choose secant as a function. On a graphing calculator, you need to do 1 over secant, or 1 over cosine in there. So you would type, if it was like secant 2x, you would do 1 divided by secant 2x. Nope, because you can't say secant. You would do 1 divided by cosine 2x. So you do need to know which is which because they're shifted. So let's look at cosecant. Cosecant has a domain where x cannot equal n pi. So if I draw the sine graph, it went like this. So each place where you had that y-intercept is going to be an asymptote, just like before. Range is going to be just like secant, where you negative infinity to negative 1 and 1 to infinity. Period's 2 pi because it's the same function. No x-intercepts, no max or min. Now let's graph it. So just like secant, you have your up and down curves. They're just shifted. And it's the reverse of what that green sine graph is. So you would do the same thing in your calculator, 1 over sine. On Desmos, you can choose cosecant. So let's try graphing a couple. So if we wanted to graph y equals 3 cosecant 2x, we would do 3 divided by, because it's like saying 3 times 1 over, and then cosecant is sine of 2x, and then we're going to graph. And now we see they're 3 apart, and it does the curves like that. On Desmos, hold on, I think I can get rid of this. Well, no. I had figured out how to get rid of it at one point. Okay, anyway, on Desmos, 3, or y equals, sorry, y equals All right, let me get back to this. Here we go. Okay, we're going to try this again. Awesome. Okay, y equals functions, trig. So if I wanted 3 cosecant 2x, it graphs it for me that way. So the calculator and the website will do that for you. All right, let's look at tan. Tan and cotan are a little bit different. They're still periodic, but they don't have that curve shape. Instead, they're just, you'll see. So domain, x cannot be the 2n plus 1 times pi over 2. So that means we're going to have asymptotes at pi over 2, 3 pi over 2, pi over 4, pi over 2. Okay. So we're going to have asymptotes. No, that's not an asymptote. There and there. The range is negative infinity to infinity. So there's no max and min because the range goes from down to low. X-intercepts are at n pi. So at your 0 pi, at your 1 pi, at your negative 1 pi. And the period is pi. So tangent goes like this. That's your tangent graph in one period. So really, it's almost like a cubic function, but it repeats over and over and over again within that pi interval. So if we were to graph that on Desmos, let's do it in a different color. Y equals tan x. You see that curve over and over and over again forever. So cotangent's the inverse. So the domain and range are probably going to be the same. Let's check it out. Well, they're a little bit different because we're flipping. So the inverse of this means where the x-intercepts are going to be the asymptotes, and where the asymptotes are going to be the x-intercepts. So here, we're going to have this as an asymptote, and this as an asymptote, because those were x-intercepts before, and now our x-intercepts are going to be where the asymptotes were before. Our range is negative infinity to infinity. So our domain and our x-intercepts have traded places. Period is still pi, and there's still no max and min. So tangent, if you remember, was increasing. So cotangent is going to flip that and be decreasing. So there's your cotangent graph. On a graphing calculator, if we did that, it'd be 1 divided by tan x, and it would graph you just like that. So that is what you needed to know from 9-7. Really, it's about knowing how to use the technology if you don't want to do it by hand. If you do decide to draw the graphs, make sure you label your tick marks, whether it's pi over 4 or pi over 2, so that I know you're doing the right period. Otherwise, you'll lose a point because I won't know you're doing the right period. Or you can take a picture of the calculator doing it. So let me know if you have questions, and that's chapter 9.